Everybody. Okay, so this video we're going to be talking about objects in equilibrium. So I'll let you read through chapter 4.5 on equivalent systems. It's basically like you got a bunch of forces acting on an object. You can always reduce it down to less, right? Like one in the x direction, one in the y direction. If you can reduce an equivalent system down to only two forces, then it's called a two-force member. So that's here in chapter 5.4. If you can reduce it to three forces, then it's called a three-force member. And you could also always reduce it, instead of, say, like these two forces, you can reduce it to a single force and a couple. So these are equivalent. And then I'll let you read through chapter 5.2 on statically indeterminate systems. And that's basically a disclaimer saying you can't solve all the problems based on the material from this course. For example, if a system moves, then it's statically indeterminate because it's dynamics. So then we'll talk about that next semester. Or if you have too many constraints and then an object deforms, then we can't solve it based on what we know from CE 270. That's another class when you talk about stress and strain and constitutive properties. So it's not that you can't solve it ever. It's just you can't solve it based on the material from this course. So then we call that statically indeterminate, and then you just leave it alone. Okay, so really focus now on chapter 5, which is all about solving for reactions at different supports. So I have, just in the book, you have these tables, 5.1 and 5.2. It shows different supports and then the reactions at those supports. And to solve these types of problems, here are the steps, which look hopefully super familiar, right? Step 1, draw the free body diagram. Step 2, pick your coordinates. Step 3, write out Newton's second law, decomposed for both force and torque. Then you just solve some math. So I'll just run through examples. That's the best way to show. So here we go. Here's a bar, like concrete, straight into a wall. And then there are two forces and a couple acting on it. So this is a fixed support here. So then if you look in the table, it's right here, fixed support. So fixed support, imagine if you try and grab the bar and pull it to the left, the wall fights back against you, right? If you try and lift it up and down, the wall fights back against you. You try and rotate the bar, there's a reaction couple fighting against you. So everything you do for fixed support, right? Here's the free body diagram. Here are the loads acting on it. And then this couple. The reactions, if you look right here, there's going to be, I'm going to pick coordinates here. So I'll pick coordinates maybe like this, x and y. So there's going to be a reaction force here. But I'm going to, right off the bat, decompose it. So I'll decompose the reaction force into components. So this is point A, so I'll call it A. This is the x component, the y component, right? So there's a two-dimensional reaction force that I already decomposed. And there's a couple here, M. The moment due to a couple at point A. So there we go, we got our free body diagram. So next, write out Newton's second law, decomposed, right? So x direction, y direction, and you sum torque about any point you want. Okay, so in the x direction, we got this and this component. Where's the angle? 60 degrees. Okay, so in the x direction, we got this plus 2 kilonewtons cosine 60, and that's it. 0, static. in the y direction, I got this, this, and the y component of that. AY, 4 kilonewtons, sine. Okay, and then let's sum torque about anywhere you want. So, for example, if you sum torque about here, then there's this force doesn't do any torque, doesn't contribute any torque, right? Only this one and this one. If you sum torque about here, this force doesn't contribute any torque, only this one and this one. Right? If you sum torque about here, this force doesn't contribute any torque. So I kind of like that one because this is unknown. So it's a way to get rid of one unknown. So I'm going to go about point A. This can be any point. So I'm just choosing point A. Okay, so the torque by this force is 0. By this force is 0. By this force is 2.5 meters for kilonewtons, and that's counterclockwise, which is positive, right? And then the torque by this force is only this component provides any torque, right? So that's 4 meters, and then only the vertical component, so 2 sine 60. And then let's not forget this, so that is going counterclockwise, so positive, so plus. And this one is also going counterclockwise, so plus. Oops. Plus. Okay, so then if you look at it, we got 3 equations, 3 unknowns. No problem, right? 3 equations, 3 unknowns. Okay, let's try another example. So here, this is a pin support, and here we got a cable or a rope. Right, so if you look in the table, you'll end up memorizing this against your will, basically. Right, so if you have any kind of rope or cable, it can only provide tension. Right, because you go the other way, it'll just buckle, right? It's not going to provide any compressive support, only in tension. And then a pin, if you look right here, can provide a force, but it can't provide any kind of couple because it's a pin, it'll just rotate. Okay, so here's our free body diagram. There's this one load, 600 pounds, and then everything else, I'm going to pick coordinates, I'll just go X and Y like this. So there's going to be a tension here in the cable, and then this is point B, so I'll just use letter B. There's a reaction at the support, which I'm just decomposing into X and Y components. Okay, so then that's our free body diagram. Now you just write Newton's second law, decomposed, some torque about any point you want. So in the X direction, I got minus T sine, right, because this is opposite, and then I got 600 also sine, and plus bx. Y direction, the y component of that, positive, cosine. The y component of this is negative, and then adjacent, and then I got this one. Okay, and then some torque about anywhere you want. So I don't want to deal with this angle over here, so I'm just gonna go about point A over here, about over here. So that the torque by the tension is 0. So then I have torque by this, but only this component provides any torque, right? And that will be negative 5, then 600 cosine, and then from here to here is 14, which is plus, and that's it. Okay, and then again we have three equations, three unknowns. No problem, right? Okay, how about this one? Right, so free body diagram. I got the one force here, and then this is a pin. It's a pin, and this is a roller. And then a roller is here. See this roller? So it can only provide one reaction normal to the surface, right? It can't provide any force parallel to the surface, because then it's just going to roll. And then it's kind of pinned as well, so it can't provide any couple. So this roller can only provide one force normal to the surface like that. But the pin can go like this. So the coordinates are here already. Right, so this is X, and this is Y, and then I'll just call this A for the roller. Okay, and then you do the same sum for Newton's second law. And then decompose and then solve. Right, so just real quick for this one, it's like it's a lot of parts, but don't get distracted. Maybe it's just one object like this. That's the free body diagram. Right, then we have a force here, a couple here, and then for reactions there's a pin. If I say X is here and Y is here, there's a pin here, right? This is a pin support here. So that's at A, so I'll decompose AX, AY. And then there's a roller here, right? So just like this. That's it. Right? Let's try this one. So here, like, maybe don't get distracted by that. This cable over here that's not really doing anything, right? It's just an object like this with a couple here and a force here, right? And then this is a fixed support, fixed, right? Which means there's I'll pick coordinates like this. So that means there's a reaction force, which I decomposed, and a couple. Okay, so that's the free body diagram. Okay, last one. So we have some object here, and then I feel like they're tricking you over here. So that's like mean. Because the free body diagram looks like this. There's a couple here and a force here. And then for reactions, this is a pin and this is a pin. Right, so I'll pick coordinates maybe like this. So at point A, there's a reaction force, which I'll decompose. And then at point B, there's a reaction force at this pin. It doesn't really matter that it's mounted on this angle, right? I'm decomposing it in terms of this X and this Y. So I'm decomposing B into X and Y components. And then that's it. Okay, so practice these and then more. I'll see you on the next video.